out. Okay. Now any biholomorphic map f from Cz to Z is, so namely any biholomorphic map must be of the form f of z is az plus b. Az is a scaling plus rotation because a is now a complex number. So complex multiplication is scaling plus rotation, and this is simply translation. So what we get are the different Euclidean symmetries, and a has to be non-zero. And any Euclidean similarity, provided it preserves orientation, is in fact of this form. So C is Euclidean in this sense, that is the natural geometry of C as a complex analytic domain is the Euclidean geometry, but with similarities rather than congruences. Okay, so your question here. Okay, so question is, what is the distance? Now there should be taken in it quotes distance preserved by the biholomorphic maps, that is the natural symmetries of H or D. Okay, we'll enter into these in some detail. For this we have to understand what are these biholomorphic maps. I'll just state the result and then understand whether there is a distance produced, preserved, and if so, is it unique, or to what extent is it unique. Okay, so this is not strictly speaking a meaningful sentence, but let me just, before entering into these detailed questions, just recall that upper half plane and the unit disk are equivalent by using the map from H to D, which will take Z to Z minus I by Z plus I. If this is not familiar, do it as an exercise. Show that the map from H to D, so I'll just say exercise here, show that this is actually a bijection between the upper half plane and the unit complex. You'll understand something by this, some geometry, some complex analysis, well, complex numbers at any rate.